The problem that we're going to be solving relating to vertical circles is number 7 on page 132. The problem is, a car drives straight down toward the bottom of a valley and up the other side on a road whose bottom has a radius of curvature of 115 meters. At the very bottom, the normal force on the driver is twice his weight. At what speed was the car traveling? So the best way to start this vertical circles problem is to draw a free body diagram. Because it's the bottom of a valley, the force of gravity will be pointing out of the circle, and the normal force will be pointing in towards the circle. From this diagram, we can derive an equation by remembering forces pointing in are positive and those pointing out are negative. Therefore, the centripetal force is equal to the normal force minus the force of gravity, because normal force is in and force of gravity is out. And remember that F of C, which is your centripetal force, is equal to mv squared over r. From the problem, we know that the radius is 115 meters, and normal force is equal to 2 times the force of gravity, whereas F of G, which is the force of gravity, is equal to times the mass times the force of gravity. Substituting 2Fg in for Fn yields F2Fg minus Fg equals mv squared over r, so Fg equals to mv squared over r, where Fg is equal to mg over mv squared equals to mv squared over r. The masses will cancel out, and you know this because the masses were not given in the problem. And then we substitute in g and r, giving 9.8 equal to v squared over 115. And eventually, that leads you to 33.6 meters per second, which is approximately 34 meters per second as the speed that the car is traveling. The key to these problems is to draw free body diagrams and from equations to know that the forces pointing in contribute to the centripetal force and those pointing out reduce it.